Okay, so super fast, hello near. I'm not gonna read these slides to you. Our story is that we are a compelling offering in this space, this smart contract development space, right? And here's why. It's easy to learn, it's easy to use, and we have some features like our account system, our account model, which makes it easier to reason about complex relationships among contracts. And in production, it's cheaper, it pays out, there's some optimizations, and it's faster. When you build an application on Near, you're using the same infrastructure that we use. So your decentralized application, your DApp, connects through Near API.js, a wrapper for the RPC interface, remote procedure call. Think, methods over the wire. You send JSON, over HTTP, and you communicate with the service that way. And then the Near protocol network takes care of your requests, whatever your requests are. We use the same technology for Near.dev examples, for Near Explorer, Near Wallet, Near CLI. We're all using the same stuff. And so that basically suggests to you that we are just as motivated to maintain high quality code and interfaces and stable APIs here. When you talk about a specific transaction that you send, your app might use Near API.js in step 1 to send in step 2 a call to the RPC interface, the blockchain layer, then apply, that's a specific name of a function actually, apply that request into the runtime layer, a virtual machine spins up, step 4 loads your smart contract code, step 5, while running that contract code, maybe reads and writes to state storage, the data on chain. And then step 6 returns the result within 200 milliseconds max lifetime for that virtual machine, 200 teragas, that's the upper limit for how long that code can run, and then back to your application. Your contracts being written in AssemblyScript Near SDK AS or in Rust Near SDK RS and deployed into the network. And again, if you want to see this broken down, the 2 previous recordings, or at least one of them, walk through this step by step. Right, so you can watch the other 2 recordings, I think 90 and 60 minutes respectively, and then that way you can cover this in more detail if you want. Let's touch briefly on collections. When you're reading and writing to state storage, we have this kind of key value pair state storage, right? And so there is a special keyword called state for some contracts. If it's a Rust contract, it'll definitely be there. For AssemblyScript, if you use a particular design, a singleton approach to designing the contract, then you'll have this keyword state, and the contract code will be in there. But otherwise, it's any arbitrary key value pair, key value pair, key value pair. So a message, a counter, or whatever. At the bottom here, we have these collections, and these collections are abstractions around the key value storage, so that make the key value storage feel like a vector or a persistent set, or or whatever, right? And so here are some of these collections in AssemblyScript and Rust, and you can see we've marked them as is it iterable? Can you clear all the values and so on to give you an idea? And if you go to docs.near.org. Look for concepts in the top navigation and then data storage on the left-hand side, you'll find this and much more documentation about how these collections work. And so when you're writing your contract, you're using these collections to communicate with the storage, with the database, you can think of it, right? That's how you communicate with it. Otherwise, it's just a key value store. You at a key, you set a value. At a key, you read a value. If you want something a little bit more sophisticated, you use these collections that basically wraps the key value store. And again, if you have any questions about this, just add it to the list.